In the first part of this lesson, we learned how to solve absolute value equations. But now in this second part, we're going to make it a little bit harder, because if we look at the problem on a screen, the absolute value is not alone on the left side of this equation. We have a 3 and we have an 8. So what we're going to do when the absolute value is not by itself is we need to start by isolating that absolute value. So we're going to solve for that absolute value. The same way we have been solving for x, we're going to solve for that absolute value. So we want that big thing, the 2x minus 5 inside of the absolute value, to be completely by itself on the left side of the equal sign. Currently, it's not by itself because there is an 8 doing an addition and the 3 doing a multiplication. So we need to solve them the same way we've been solving two-step linear equations, as we learned in lesson 3.2. So we start with the addition subtraction. That means we need to start with a positive 8, and the inverse operation of a positive 8 is a negative 8. So we can cancel the 8s. But if we subtract it by 8 on the left side, we also have to do it on the right side. And now we perform the operation of 71 minus 8, which is equal to 63. But the absolute value is still not fully isolated because we still have that 3 multiplying outside of the absolute value. So we divide by 3. It's always doing inverse operation. Every time we need to move things around in equations, we can use inverse operation. So we divided by 3 to cancel the 3's, and then we divide by 3 the right side. 63 divided by 3 is equal to 21. And guess what? Finally, our absolute value is by itself, is alone. There is nothing else besides the absolute value on the left side of the equation. So that is our first objective. When the absolute value is not alone, we need to isolate it. That absolute value needs to be completely by itself on either side of the equal sign. It doesn't matter if it is the left or the right, but it needs to be by itself. Let's clean this up because we need a space to keep solving. The equation is still not solved. We still don't know what the value of x is. But now we reach the part that we are familiar here. Once the absolute value is fully isolated, all we have to do is consider both positive and negative solution of the absolute value. So this is the part where we break it into the negative 21 and the positive 21. And if you pay attention, this is the same problem we solved in the first part of this lesson. So all we did was the extra steps of isolating the absolute value. But for practice, let's review how to solve this problem. Let's start with the left equation. We can start with either one. But let's start with the left equation. We have the minus 5. We have the 2 multiplying the x. And one more time, this is a two-step linear equation as we did in lesson 3.2. We start with the minus 5. And we do the inverse operation, which is a positive 5. The 5's cancel, but we need to add the positive 5 on the right side as well. And then minus 21 plus 5 is negative 16. Now we do the multiplication. The 2 is multiplying the x. So we divide both sides by 2 to cancel the 2's on the left. And negative 16 divided by 2 is equal to negative 8. Then we move on to the right side. We do the inverse operation of the negative 5. So it's positive 5 on both sides. 21 plus 5 is 26. Then we divide by 2 both sides. And we get the same answers that we got in the first part of this lesson, x equals 13. So the difference between these problems and the problems we learned on part 1 of this lesson is, if the absolute value is not fully isolated, we first need to move everything to the other side until that absolute value is by itself. And after that, we move on to taking care of the negative solution and the positive solution.